video is about formula derivations in pure 1 trigonometry. The first one is special angle triangles. If you look at this right angled triangle here, 45 degrees means this angle is also 45 degrees, which means it's an isosceles triangle. And if this length is 1, this must be also 1. And using Pythagoras, we get the hypotenuse √2. And using the definition of trigonometry, sine 45 is equal to sine is opposite, which is 1 over hypotenuse √2, so 1 over √2. And cos 45 degrees would be adjacent over hypotenuse. Tangent 45 degrees would be opposite over adjacent. And if you simplify things, 1 over √2 can be rationalized, the denominator, so that we get √2 over 2. And for 45 degrees, 1 over 1 is 1. And now for 60 degrees. 60 degrees means we have an equilateral triangle, equilateral. Let's say the length is 2, so all the lengths are 2. And now if we split this equilateral triangle in half like this, we will get this kind of triangle. You see this triangle here, so it's a right angle triangle. And of course we have the angle 60 degrees on top, so we have only 30 degrees, and this angle is still 60 degrees. And of course the length here, if we divide by 2, we get 1. So that's how we get this 1. And this 2 is of course from here, the hypotenuse, and this √3 is from Pythagoras. Now sine 30 degrees, so you want to look at the 30 degrees. Sine 30 degrees is 1 over 2, so this is 1 over 2 sine 30 degrees. And cos 30 degrees is cos adjacent hypotenuse. And for tangent, we get tangent equals opposite over adjacent, 1 over √3, which denominator can be rationalized into this √3 over 3 then. And for cos 60 degrees, now we focus on the 60 degree angle. 60 degrees is cos 60 degrees, yeah, usually we use sine first. Okay, cos 60 degrees is adjacent over hypotenuse. Sine 60 degrees would be opposite over hypotenuse, and tangent 60 degrees opposite over adjacent, which is simply √3 here. Okay, and now special angle 0 and 90 degrees. Let's start by labeling the sides here. Let's call it y and x. The sine is of course y over r, the cos is x over r, and the tangent is y over x from the definition. Now when the alpha angle approaches 0, so if this hypotenuse here, we rotate like this until it reaches 0. Of course, when the angle is 0, the x would be equal to r. So as you can see, if we rotate like this, the length of the x will be increasing and the length of y is decreasing, of course. So we have, when the angle is 0, x equals r and the y equals 0. So the sine becomes 0 over r. The cos is x, which is r, so r over r. The tangent is opposite, which is 0, adjacent, which is x or r, same thing. This is y, sine 0 degrees is 0, this is 1, and this is 0. For 90 degrees, now we rotate in this direction. So as we rotate in this direction, we make the angle bigger and bigger and bigger. The x value will be smaller and smaller and smaller to 0. The y value will be approaching x. So the y value is approaching, the y value approaching r. So this is r. The y happens to be r. when the angle is 90 degrees here, and this is 0. So sine 90 degrees would be opposite over hypotenuse, adjacent hypotenuse, and the tangent is it is the angle here. This is the 0 degrees and this is the 90 degrees. We want to make it 90 degrees. So tangent opposite, which is r or y divided by adjacent 0, and this explains why tangent 90 degrees is undefined, because we have something divided by 0. Now SOHCAHTOA is for sine equals opposite over hypotenuse and so on. So sine divided by cos is therefore sine is O over h, so it's O over h divided by cos, which is A over h. Now we keep, change, flip, we get this, and of course we can cancel out. H divided by h is 1, and so we get O over A, which is equal to tangent. So this explains why tangent is equal to sine divided by cos. The Pythagorean, so let's say we have this triangle, hypotenuse, the opposite, the adjacent. Now using the definition again, sine theta is opposite over hypotenuse, which means the y is r sine theta. So this y is actually r sine theta, and using cos we get the same thing here, x equals r cos theta. Now using Pythagorean theorem, x squared plus y squared equals r squared, but the x is r cos, the y is r sine, and we get r squared cos squared, r squared sine squared, divide throughout by r squared, we cancel out everything, we get the Pythagorean identity. Complementary angles. So using definition again, sine is y over r, opposite over hypotenuse, adjacent over hypotenuse. But now look at this triangle here. If this angle is theta, this angle is 90 degrees. Of course, the other angle would be 90 degrees minus theta. Now if we focus on this angle here, the sine is opposite over hypotenuse, which is x over r. So that's the sine. And the cos would be adjacent over hypotenuse. So cos adjacent over, wait, the cos is adjacent, that's y. This is y. Adjacent y, so y over r. Right? Now, if we just look at this x over r, this is also x over r. So that means this cos theta is of course equal to sine 90 degrees minus theta. And if you look at this y over r, of course that means sine theta is equal to cos 90 minus theta. So that's the complementary angles formula. Translational angles. So we know that this is the basic shape of a sine graph, the basic shape of a cos graph. Now, if this is the f of x, if sine is the f of x, if you just look at the pattern here, if we slide this sine graph, if we slide this sine graph 90 degrees to the left, we will get exactly the same as the cos graph, because this continues forever, of course, this continues forever, right? Exactly the same shape. So that means the cos x here is exactly the same as the sine graph, but we translate 90 degrees to the left, and translating 90 degrees to the left means we add, remember, in transformation, so plus